Okay, so let's go ahead and do some polar graphing. All right, here we go. Polar graphing. Okay, so I tried to give you one of each variety here. So what I started off with, I need to move that thing. Okay, is this is a circle. So again, anytime you have either an r cosine theta, um, sorry, an r equals say something like a cosine theta or r equals a sine theta, it's going to be a circle, and a is the diameter of that circle. And if a is positive, it's either going to go up or to the right, and if a is negative, it's down or to the left. This is a cosine, so it's going to have x-axis symmetry, and that symmetry is again going to push to the right. And so its diameter is 16. So we're going to have 16 at angle 0. And you'll notice that I put in these little red dotted lines at a radius of 8 because I found that to be helpful. Now remember, the cosine of every kind of pi over 3 is a half. And so at the angle pi over 3, that's a half of 16, which is 8. And at pi over 3, I also have down here 8. And so we have ourselves a nice little circle who has a radius of 8. And I'm just going to go ahead and use the fact that I know this is a perfect circle to go ahead and use my compass here to make a nice circle. Now, again, if your circle isn't perfect, it's not a big deal. I'm just trying to show that that's how it should work. And I don't think I did that absolutely perfect, but it's probably better than I would do if I freehanded it. Now, you'll notice this is a sine, right? And a sine is going to have y-axis symmetry. There's a plus, and so it's going to be extended to the high side of that number. And this shape is called the limicon. Now, this particular problem is one in which it does have a loop because the second number is larger than the first. So remember, one of the things that I told you is that if you were going old school and graphing this, 6 is your middle line with an amplitude of 10. And what makes it actually have a loop-de-loop is that there is this region down in here where the radius is negative. And you'll notice it has a radius that goes all the way to -4. So what I'm going to do is I'm going to start off going up to my radius of 16 up here. I know it's going to have a loop-de-loop of 1, let's see, 1, 2, 3, 4. One thing that I find to be very, very helpful is that this 6 is, although I'm supposed to really be eyeing the y-axis, this is the value that's going to happen at the x-axis. So 8, 7, 6 is going to be here and here. Again, that 8 helps me a little bit. And if I wanted to make it look a little bit better, I know that the sine is really pretty at all my pi over 6s. So the sine of pi over 6 is going to be a half. And so I'm going to get a half of 10, which is 5, plus 6 is 11. So 8, 9, 10, 11. So that's one of the reasons I really like to have 9, 10, 11, something like this. So I have my graph kind of coming like this, and then it's going to loop in here and do a little loop-de-loop like that. And I could put in here that this number, half of 10 would be 5, and 6 minus 5 would be 1. So the radius right in here at the pi over 6s would be 1. Okay? Now, moving a little bit further, we now have a cardioid. And it's a cardioid because those two numbers are, in fact, the same. And this one is going to basically skew on the downside. So here is 8, 9, 10, 11, 12, because 6 and 6 makes 12. Keep in mind, again, I'm focusing on the x-axis, but the y-axis, but that means on the x-axis, it's at 6. So I'm just going to slide in 2 units from my 8 that is there. And we know it has this kind of shape, but if I want to make it look a little bit better, I'm going to take half of 6, which is 3. So, and again, at pi over 6s, remember the sign is some kind of a half, and half of 6 is 3. So I'm either going to add 3 or take 3 away. So since this one is skewed on the downside, half of 6 is 3, plus 6 is 9. So at the pi over 6s, I'm going to be at 9. And so I can kind of go like this and look like that. And 6 minus 3 would be 3. So 1, 2, 3. It's going to be the really little guy like this, kind of looping in here like that. And half of 6 is 1, 2, 3. Hopefully I've hit that okay. And that's my cardioid. So I kind of like picking points like this, where at the angle 11 pi over 6, I had a radius of 9. And I have the same one right here. That just helps me make it look better. Okay. And last but not least, we have a rose. And a beautiful thing about a cosine rose is it always has a petal at 0. That's amazing. So I know I have this petal that goes out 16 units. My target, I told you, for a cosine was I love pi over 3, right? Because that's where it's a half. But that pi over 3 is going to turn into pi over 12 because remember, in graphing by transformation, this says multiply theta by 4. So I'm going to divide by 4. And I like it because that's the place where it hits a half. And so my radius would be 8. And I picked all these numbers very meticulously so I wouldn't have to work quite so hard. So I know at the angle pi over 12, its radius is 8. And so that's what the first petal looks like. And as it turns out, I know there are a total of 8 petals. So if there is 2 pi in a full circle, I'm going to evenly distribute 8 petals. That means there's going to be a brand new petal every pi over 4. So there's going to be a tip here, one here, one here, one here, 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 and here. Hopefully I spaced those all out right. And I also find it sometimes helpful to draw in little lines where the center of my petal would be. I just find that helpful to me. Oh, I put that one in the wrong spot. I'm glad I stopped. Okay, so I'm going to have to ignore one of those lines. Because I notice this petal, see right here, the middle of the petal goes up one line and down one line. So if I can go up and down one, I would be able to come up with a pretty nice one. Go to the middle, go over and back one. Here, go to the middle of the petal, go over one and back one. Same thing here, up one, down one, etc., etc., etc. But I feel like I should probably finish because I'm this far. And so I would like to see how well I did. I tend to get a little lazy when I get far into these. But that looks pretty good. And of course, on all of these, you easily could graph them, just making sure you put your calculator in polar mode. So again, if you go down and put it in polar mode, that's going to allow you to take a look at these values like 16 cosine of 4 theta. And you'd be able to see if it looks right. And so that looks okay. Of course, my window doesn't look wonderful. So usually I hit zoom standard to kind of make a normal window, and then I'll hit something like zoom square to make a square look like a square. Still doesn't look great because again, my window only goes -10 to 10, and I really should make it go out a little bit. So maybe I should make it go, somehow I guess I didn't hit the zoom square right. Zoom 5. Okay, there we are. That's now a square is a square. But I'm going to go ahead and make this a little bit bigger, maybe make it go from -25 to 25, and maybe make this -5, make this -16 to 16. And maybe that will be pretty close to what it is that I'm looking at. And that looks appropriate. I feel like my petals are a little thinner than they should be, but it's not too bad. Okay, I'll see you guys back in class. Bye-bye.